So you're looking at standard A1. This is going to be a pretty short standard, and we've actually already done problems where I've had you find average value. We've just never narrowed in on it. So that's basically what this is, making sure that we know how to do. So what do I mean when I use the word average? For example, how would you find the average of 2, 6, 8, and 12? Hopefully what you would say would be that to find the average of all these numbers, you're going to add them all up and divide by how many numbers there are. So in this case, 4. So we'd have 16 plus 12, which is 28, divided by 4, which is 7. If I asked you to find the average rate of change of this function between so if I asked you to find the average rate of change of that function between x equals 3 and x equals 6, how would you set that up? Now, average rate of change we've done a lot with. When you do average rate of change, that's like finding the slope. So, but between two numbers, you would find f of 6 minus f of 3, and then divided by 6 minus 3. So f of 6, 6 cubed is 216 times 4 gives me 864. When I plug in 3, 3 cubed is 27, 27 times 4 gives me 108, all divided by 3. So it's 828. Oops, nope, it isn't. I missed a button. 252. Alright, so average rate of change, we still have the idea that you're doing something and then dividing by the range of values that you're looking at. So if I'm asking you to find the average value, that is not the same thing as average rate of change. Rate of change, slope, is how the difference of your y values is affected by the difference of your x values. So when we talk about average value, the first question we need to answer is how do we find the value? Now, if you think back to the several definitions we've talked about with integration, one of the definitions that I've hammered in to your head, hopefully by now, is that integration finds the area underneath a curve, but integration also finds the accumulation of value. So like when we've been doing volume and area, we're talking about like slicing it up and then adding up all the slices. That's accumulation of value, accumulation of all the individual volumes, accumulation of all the different areas. So that's what I'm talking about when we talk about value, is you're talking about integration, accumulation of value. So if I'm looking for the average value means you're going to be integrating some kind of function, but then you're going to be dividing by the range of values that you have. Well, the range of values you have is the space between b and a. So to show that, we're going to put 1 over b minus a in front. Now, if you integrate and evaluate it, you get f of b minus f of a after you integrate it. And then you'd be dividing that by your range of values. It's going to end up looking a lot like rate of change, but because you integrated first, this means average value, not average rate of change, because you're dealing with integration first and then dividing. Okay? So in words here, you're going to integrate the function, evaluate, divide by the range, how do I want to word that? And divide by the range between your limits of integration. Okay, here we go. So, finding average value. The two words, this is how you know you're supposed to find average value, is when they use the words average value. So your directions would say something like, find the average value of f of x equals cosine x over, and then they'll give you an a and a b. Okay? So if you're finding average value, you have to find the accumulation of value first before you can find the average. So you would integrate it from 0 to pi over 2. Now, I always put the 1 over b minus a, because eventually that's going to make you divide by the limits of your integration. You can put that there initially, or you can just divide at the very end. It doesn't really matter, just don't. I always put it there so I don't forget to divide when I'm finding average value. Okay, so when I integrate cosine x, I get sine x. There's no inside function here, so I can just do the straight rule, integration rule for cosine. And then 1 divided by pi over 2, if I flip and multiply, that means I'd be multiplying by 2 over pi. And I'm going to evaluate that from 0 to pi over 2. So, when I plug in pi over 2, I end up getting 1. So you get 2 over pi times 1. That's f of b minus f of a minus. When I plug in 0, sine of 0 is 0. So you end up getting 2 over pi units squared. So that's the average value that you're accumulating over that time frame. Now, if you did it the other way, so if you didn't put this out in front and you just evaluated it, it's going to look very similar. You're still going to have sine x. You're going to evaluate it from 0 to pi over 2. What you would find is then that value is 1, and then you would take 1 and divide it by pi over 2, because that pi over 2 is the space between 0 and pi over 2. You would still get 2 over pi. So the dividing can go in front, so you remember to do it, or it kind of becomes part of the problem, so you do it automatically, or you can integrate and then divide. Either way will get you the same answer. Okay, so we're going to look at example 2 here. Find the average value of f of x equals 4x squared plus 4 divided by x squared over, I give you a range, 1 to 3. Okay, so average value. Value means accumulation of values, so integration. So we need to set up my own integral here from 1 to 3. I'm going to integrate this function from 1 to 3. And again, you can put the division there automatically in the front. So we'd have 1 over 3 minus 1, or 1/2. I'm going to go ahead and do that here. Or you could leave that part till the end. It doesn't really matter. When you put it in here in front, all it does is automatically include it, so you don't have to worry about it later. Okay, this integral, I'm going to simplify first because I have a single value or single term on the bottom. I'm going to do the heart problem here and split it up into 2 integrals. So 4x squared divided by x squared just gives me 4. And then I'd have 4 divided by x squared, so I have 4 times x to the negative 2. It's a little bit easier for me to integrate. Okay, so integrating, I get 4x, add 1, divide, get negative 4x to the negative 1. I'm going to evaluate that from 1 to 3. Now, f of 3 minus f of 1. Again, this 1/2 represents me automatically dividing to find the average. So evaluating 3 and 1, I end up getting, I think, 5.333 or 16/3. So if I plugged that into my calculator and used my table and subtracted, I get 16/3. Again, the other way that you can look at it, if we use the simplified version here, is that you integrate first, punch it out. So if I punch it out, I get 12 minus 4/3 and subtract 4 minus 4, so 0. So you get 10.667. And then to find the average, you divide by the space between 3 and 1, which would be 10.667 divided by 2, which is 5.333. So we get the same answer here in both cases. Again, the average, you just need to make sure you either do it at the beginning, so it's automatically included, or integrate to find the value, and then divide by the range between your limits of integration to find the average. Okay, so that's basically that standard. Yeah, and we'll practice it tomorrow and work on it a little bit more. But this is a good break, at least from the volume stuff that's a little bit more intensive.